Hello, today is Unit 3, Formative 3, Day 2. It's the substitution. So we're going to solve systems of equations by substitution. Yesterday we solved systems by graphing, where we graphed the two lines and where they met was the answer. Well, this is just a second method to solving systems. Now, if you graphed and if you did substitution, you would end up with the same answer. Alright, so substitution is just like we've done in the past. There's going to be more algebra involved. For example, like what we've done in the past is if we had 2x plus 3, and I said, well, what if x equals 4? You would take the 4 and substitute it in for the x, and you would have 2, and instead of the x, you'd have a 4 plus 3, and then 2 times 4 would give you 8 plus 3, and then you would get 11 as an answer. So it's very similar to that, except there's going to be more algebra, longer terms involved. Right. Again, this is just another way to solve systems. You could graph these and get the same answer. Alright, first one. We have 2x plus 2y equals 38, and then we have y equals x plus 3. What we want to do is we want to take one equation, okay, and substitute it into the other one, just like we have x equals 3. Here it says y equals x plus 3. Now this is nice because it's telling me what y equals, and I know y equals x plus 3. So in my other equation, instead of the y, I can plug in x plus 3 because I know y equals x plus 3. This is the substitution part. So this is going to be step 1. Okay. Actually, step 2. Step 1 is make sure one equation equals x or y. Okay. In this case, it equals the y. Step 2 is going to be make the substitution. Alright, so I'm going to go ahead and do that. Again, it says y equals x plus 3, so in place of this y, I'm going to put x plus 3. 2x plus 2. Now instead of the y again, I'm going to put x plus 3 equals 38. Now here I have x's, so I need to solve for x. Now remember, in systems of equations, you have an x and a y as an answer. So in this case, this is going to give me my x's as an answer. Alright, so I'm going to go ahead and distribute, because we always have to distribute first. 2 times x is 2x. 2 times 3 is 6. Okay. Combine like terms. 2x and 2x is 4x. Plus 6 equals 38. Now subtract 6. 4x equals 32. So x equals 8. Alright, there's my x answer. Now again, you need an x and a y answer. So now I need to go back and find my y answer. Okay, so this would be step 3. You're going to solve for x and y. Okay, we already got the x, so now I'm going to go back and solve for the y. Now, here's the thing that's going to make things easier or make things difficult. I am going to take x equals 8, and I can plug it into either one of these x's here. This one will be the easiest one, always. Okay? So the one that has the y equals, okay, is where I'm going to go back and do my substitution. So I'm going to go back and plug this 8 in for the x. So I have y equals, now instead of the x here, I'm going to put an 8 because x equals 8, and then plus 3. And 8 plus 3 is 11. There's my x answer and there's my y answer, and your answer has to be in a point, just as if we were graphing. So my answer is 8, 11. Again, remember, this is your x, this is your y. Now I know that was a lot of algebra, but it's nothing new, just as the amount of time it takes is new. So let's try another one. Alright, we actually don't need this. Okay, on this one, you can see my x equals 3y plus 3. So I'm going to take my 3y plus 3 and replace the x in the other equation. Okay, so step 1 was actually done. Step 1, remember, was solve for x or y. And this is actually done for us because this one's already solved for x. Step 2, substitute. Right, I am going to take my x, which is 3y plus 3, and plug it in for the x. Right. So we have 2. Again, instead of the x, I'm going to put 3y plus 3 plus y equals 6. Now you notice here, there's only y's. If you had an x and a y here, you did something wrong. Okay, so there's only y's here. Now I'm going to solve, so I have to distribute first. So I get 6y plus 6 plus y equals 6. Combine like terms. That's 7y plus 6 equals 6. Solve for y, so I'm going to subtract 6. 7y equals 0. Divide by 7. So y equals 0. So now I have my y value. Now I need to find my x value. And that was, again, step 3, which was solve for x and y. We got the y solved for, so now I need the x. So I'm going to take this, I'm going to plug it back in. Remember, this one's going to be my easier equation. Okay, the one that was originally solved for x or y will always be your easier equation in your substitution. So I'm going to have x equals 3. Now instead of y, instead of this y, I'm going to put a 0 because y equals 0. And that goes away. And x equals 3. So my answer is 3, comma 0. Remember, your x, then your y. Now, if you remember when we were graphing and we had infinitely many solutions, remember that was a line that was on top of another line? So it's actually 2 lines, but it looks like one. Okay. Now, we're not graphing, so how do we know if it's infinitely many solutions when we're not graphing? Okay. And then when we had a no solution, remember the lines were parallel? Okay, so we know they never met. But if we're not graphing, how do we know lines are parallel? Okay. So here's what's going to happen with our answers. Okay. Infinitely many is going to be an identity where 2 equals 2. So this one is going to be a true statement. Okay. Infinitely many is going to be a true statement. Now, on the no solution, that's going to be a false statement. 8 equals 4. 7 equals negative 7. So these, a no solution is going to give us a false answer. Let's try 2 of them in substitution. All right, I got my first one here. Again, my first step is going to do my substitution. So I'm going to take negative 2y plus 4 and substitute it in for this x. So I'm going to get 3.5. Now instead of x, I'm going to do negative 2y plus 4 plus 7y equals 14. Okay. I'm going to distribute. 3.5 times negative 2 is negative 7y. 3.5 times 4 is 14 plus 7y equals 14. Now I'm going to combine like terms, negative 7y and a positive 7y. That gives me 0, so I end up with 14 equals 14. Now you notice my y values disappeared. I don't have y equals 14 or y equals 7 here. Okay. Now it is a true statement. So this would be an infinitely many solution. This is where it looks like it has one line. It looks like one line. On a graph. All right, let's try the other one. So on this one, I'm going to take, because it's y equals 3x minus 11, I'm going to plug that in for the y. So I have 3x minus 11 minus 3x equals negative 13. Combine like terms. 3x minus 3x is 0, so I have negative 11 equals negative 13. Oops. Notice what went away again. My x's went away. My variable went away. And I have negative 11 equals negative 13, which is a false statement. So this is a no solution. If we were to graph these would be parallel lines. Now you notice on the infinitely many and the no solution, both times the variables went away. That will always happen on those. X equals 0 is still a solution. So your x's and y's have to be eliminated in order for it to be infinitely many or no solution. Otherwise, it's a one solution. All right, guys, have a great day.